So in this series of videos, we're going to be working with the Johns Hopkins University COVID dataset that Johns Hopkins University collected about the spread of COVID-19 at the beginning of the pandemic, so in early 2020. And I have gone through and augmented, so I went through and downloaded all of the data and put it all in a place. And for a while, I was running my own analysis every day. So I had these data, kind of most of them sitting around, but then I augmented that data source with a couple of other ones that are kind of interesting. An election data source from the New York Times and population information from the US Census. And this is really typical of this type of analysis where you might have one data set, like you're interested in the spread of COVID, for instance, but then you can't really talk about the story of the spread of COVID without talking about population density and increasingly belief about things like vaccines and vaccine effectiveness and the ability or appropriateness of the government mandating masks or other public health measures. So there's a whole bunch of pieces in here, and in some sense we have to continually bring in new data sources in order to help us answer these questions. So you should have already kind of built this data model in a previous assignment, but if not, you can go ahead and pause the video and get this thing situated. This is from the COVID US Excel file, so each one of these pieces is a sheet. You could also do it where each one of these is a separate CSV. There's really no functional difference, but this is what your overall data model should look like. So let's get started on actually doing some analysis here. So if we go over to our sheet, the first thing we notice is that we have a lot of geo fields, and that's good. This is Geospatial lecture series, but we can do some stuff with these. So the first thing I typically look for here is whether there are natural hierarchies to be found. So for instance, I see county and state here. So I'm going to drag county into state, and I'm going to call this location. And I'm going to drag county into state here. I'm going to call this location. And I have to call it, so I may just do that again quickly. So it says you can't call this location because it already exists. So I'm going to call it location. And then following the Tableau convention, I'll call it location population to say that this is the location hierarchy that comes from the population data frame. And then we could do the same thing here, like if we wanted to do this into region, like this, and so on and so forth. The reason we do this again is to allow the user to drill down. So if you don't do it now, it's okay. You can do it later as the drill down opportunities present themselves. But let's get started here. So let's drag in location into detail, and notice what we get right off the bat. We get a geospatial scatter plot. So each point here is a different state, and that's because I'm at the state level of detail. If I expanded this out to county now, each dot is a county, and this is obviously overwhelming. But if we go down here, notice that the dots here are not in any kind of particular place in terms of towns or the capitals or anything like that. These are just the geographic centers of the state. So, for instance, the capital of Alaska is Juneau, which is down here, I think. Capital of, I can definitely, well, that's a silly one. Tennessee, it's pretty close. Capital of Maine, that's pretty close too. It's like all of these are pretty close. But the default in Tableau is to put the point at the geographic center of the area that you're plotting. We'll talk in a future video about how to change that, because oftentimes you want it to be at the state capital or something like this. So what can we do? So this geospatial scatter plot is one way to approach this. And just for simplicity, I'm going to take continental United States just because it's a little bit easier to deal with here. So if we go keep only, so I selected the things and then hit keep only. So I'll do it again real quick. So I just select these things, hover over, and then say keep only. This just gives us our continental United States. Now, one of the things I don't like about Tableau over here is it's not super easy to pan. Like so here I'm kind of like scrolling and scrolling out. That's to be expected. If you want to pan, you have to go to this sideways arrow and then select the move thing. And yeah, that's better. Okay, excellent. So we have a geospatial scatter plot, but let's talk about choropleths or heat maps. So here what we're going to do is say show me, and then select this one in the middle here. So now notice that we go from having a kind of a dot map to having a filled in map. And this can be pretty useful because you get to see which area you're talking about. It'll be more useful in a moment when we talk about talk about counties. But let's talk about just confirmed cases. So confirmed here, we're going to drag it up to color. And this is exactly what you would expect it to be, essentially. It's a heat map where, and we have our bar over here, where the kind of the lowest color, the lightest color is 0 cases, and the biggest color is around 600,000 cases. And notice the aggregation here is some. So what we can see already, and this is useful, is that some states like California have a lot of cases, total cases over the time period. Some cases like Montana have very, very few. And then the reason we care so much about the hierarchies that we did earlier is because now, if we go through and kind of blow this up a little bit, we can see even within states like California, so California had a lot of cases, but within California, it's not at all distributed uniformly. It's in fact just LA County and the surrounding suburb counties, and a little bit in the Bay that are driving those infections, at least in this time period. Same thing with Florida. Florida is a big state. And in fact, it's just South Florida, like Miami-Dade County, that's causing that number to be large. Same thing with Cook County in Illinois, which is where Chicago's located. And so what this is doing for us, essentially, is telling us that these major metropolitan areas like LA and Miami and New York City and Chicago, they're driving the infections. Sorry, they're driving these infection numbers, the confirmed numbers up. Now, that's not surprising. You know, if there are more people there, there are going to be more COVID cases there, just because there are more people. You know, so what's the deal? So in all of these situations, we typically need to look at a per capita basis, and this is where our role as a data analyst becomes really, really important, because we could stop here and just say this is the story that the data is telling, but that would, in my opinion, be really disingenuous, in the sense that it's not actually giving people the actionable information they need to make good decisions. What they need is a per capita situation. And they need both. They need the absolute count, because absolute count in this case, for instance, is what overwhelms hospitals. But we need to know proportionality, because that's the places where there's a lot of suffering occurring on a per person basis. So let's make a new calculated field, and we'll call this confirmed per capita. And it's going to be exactly what you expect, except that we need to remember our level of detail stuff. So I'm going to do it wrong, and then I'm going to do it right. So remember, if I do it like this, confirmed divided by population, this is not right. This is not correct. And the reason for that is because, oh goodness, we are making a fraction and then summing the fraction. That's not right. We actually just want, in a particular location, we want the total number of cases divided by the total population. If instead we take the fraction first, we're going to basically ignore the population size when we start to sum the fractions. We've already taken out that piece. So we're going to say sum of confirmed divided by sum of population. Why is it giving me an error? So this is live debugging. Oh, okay. So I think it's getting confused that there's a population field in the population frame. So you see what it's saying? It's saying sum is being called with a table. Did you mean float? No, I actually meant this field here. So I'm gonna hit OK and see if this works. And I think it should. So let me drag this to color. And if not, we'll do a little. Oops, so it's not working at all. So let me edit. Let's call this population. That one, like this. Good, calculation is valid. Sorry for the live debugging, actually, and it's so funny. Like, I don't think I've told you this in previous videos, but I have a script over here that I've written for myself that has every action, so that these videos are not me just kind of like trying to remember what I was supposed to do. And even in my script, I didn't have this one. But the issue here is that we have a table of data frame, a sheet called population, and within that we actually had a field called population, and Tableau was getting confused about which population we meant at that point. And it's just a matter of looking at the error message and trying to divine what that means. Okay, anyway, so now we're ready to go. Our little mad exclamation point is gone. We're going to drag this thing up to color. And now we get a much different story, actually. Like, look how different this map looks. This is why this is so important. Over the course of the pandemic, represented in this data set, and this is the early part of the pandemic, it's actually saying that states like California that we thought were quite bad are actually better than places like Louisiana or Mississippi or Alabama or Arizona on a per capita basis. The fact that California looked worse, at least to start with, was because it has a larger population than those other places. If we expand this down to the county level, we can see that it's no longer necessarily the population centers that are showing up. Like, I'm from this county right here, Shelby County, Tennessee, and I can tell you that these counties in Arkansas that are kind of like this little hot spot, this is a very rural part of the country. There's not a large population center there. And the same thing for, Lafayette County, Florida, and all these other places. My point is this: geospatial data is really interesting. My points are these, I should say. Geospatial data is really interesting. The level of detail is very important because, as we're seeing, looking at things at the state level and looking at things at the county level tell different stories. And in addition to that, we still have to worry about all of the same stuff related to level of detail and hierarchies and all of this that we did before in order to make sure that the story we're telling is actually accurate. So more on this as we go through. We're going to talk about scatter plots and more complicated things as we go. But for now, we'll call it a day.